In this video, we will show how to provide a PDA for the language. L is the set of strings W, such that W is an element of the alphabet 0, 1, and the length of W is odd, and its middle symbol is a 0. So we looked at this same language in terms of context-free grammars in a previous video, but just to remind ourselves some strings that are in the language, so W's in the language, for strings like 0, 1, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 0, 0, and some strings that are not in the language. 1, we add one over here, so just the string 0. Sorry, back to strings not language. 1, 0, 1, 1, 1, 1, 1, 0, 0, 0. Okay, so we could go on forever, but these are some sample strings. So, what we know is that a string is going to be in the language if two conditions are satisfied. One, that 0 has to be the middle of the string. So we could say we have W1, 0, W2. Okay? So what further conditions do we have on W1 and W2? We have that the length of W1 has to be equal to the length of W2. Okay, this is required when we say that 0 is in the middle of the string. This also actually gives us, let's call that K. This gives us the fact that this is an odd length string, because any string with this form is going to have length 2K plus 1. The 1 came from the 0, and this by definition is odd. Okay? To double check this, if we have the string just 0, then K is 0, and this length is 1. If we have the string 0, 0, 0, then K is 1. So we have 2 plus 1 is 3. We get the odd length with the 0 in the middle. And same thing, we could keep going through this list to prove this. Okay, so this insight is going to tell us how to build our PDA. So what we need to do, we need to have some way to make sure the middle symbol is 0. And we also need to have some way to make sure, so these are our two conditions basically. Okay, condition 1, middle symbol is 0. Condition 2, we're going to use this, length of W1 is equal to length of W2, where W equals W1, 0, W2. Okay? So those are two conditions we need to check. Excuse me. So what we're going to do is we're going to use non-determinism to guess the middle of the string. Okay, we're going to guess basically the location of this 0. And what we're going to do is we're going to have, so we have phase 1 is going to be, we basically want to count the length of W1. I'm going to leave a gap here. Phase 2 is basically just going to say transition to phase 3. Okay, and phase 3 is count length of W2 and compare to W1. Okay, so how are we going to achieve these phases? Well, first, let me move on. So counting the length of W1, the idea is we're going to push a pound symbol. Why pound? Just because. I picked a symbol. It could really be any symbol. Push a pound symbol to the stack for every symbol read in W1. Okay, that's how we're going to count it. The number of pound symbols on the stack is going to be the same as the length of W1. Phase 2. I say here transition to phase 3. Let me skip that one for a minute. Phase 3. We need to count the length of W2 and compare it to W1. We actually do this in one step. We're going to pop a pound symbol from the stack for every symbol read in W2. Okay? So I haven't said how we check to make sure that they're the same, but this is what we're going to do. Phase 2, we're going to transition to phase 3. What this means is guess middle of string, and transition if and only if symbol is a 0. Okay, so let me back up. Phase 1, we're just going to read through W1. We don't care what symbols it has in it, we just care how many. For every symbol in W1, we're going to push a pound symbol to the stack. Then at some point, we non-deterministically decide this must be the middle of the string. And we're going to transition into another state in our PDA on the symbol 0. And notice here, I should have added without touching the stack. Okay? This is just saying I'm at the breaking point. I'm the middle symbol, so transition over to the next phase. And then in phase 3, we're going to go back through and read all of the symbols in W2. We don't care if they're 0s or 1s, but for every symbol we're going to pop a pound symbol off of the stack. Okay, so how do we decide to accept? Okay, so that could be phase 4 or just the acceptance phase. Okay, we're going to accept if we reach bottom of stack after reading all input. Okay, in other words, what we're doing is we're going to push K pounds to the stack for W1. We're going to pop N pounds from the stack for W2. Whoops, W2. Okay, so we accept only if K equals N. Okay, to be sure that this is the case, notice some things. Now, we haven't built our machine yet, so this is still in the design phase. Let's say if K is greater than N, what happens? We have pound symbols left on stack. Okay, so we're not going to accept. We haven't reached the bottom of the stack after we've read all the input, which means we have some number of pound symbols left on the stack. And this is obvious because we pushed more than we popped. Okay, so then we don't accept. Let me make a little don't accept on these conditions if K is greater than N. If K is less than N, okay, we're going to we're going to not be able to how do I say this? We're going to reach the bottom of the stack before we're able to pop N symbols. Okay, so in this world, we're not going to be able to take some transition because it's going to require us to read a pound symbol on the stack, and it's not going to be there because we've already popped them all because K was less than N. We didn't push enough. We didn't push as many pound symbols as we needed in order to pop them all, so that's going to be a problem. If guess middle, and it's not a 0. Okay, so I'm saying I'm guessing the middle position of my string, and let's say it's a 1, right? The only other symbol possible, it's a 1. We're not going to be able to take the transition to phase, what did I call it? 3, phase 3. Okay? So basically these are the ways that a string could fail. Either, you know, the two sides aren't equal, which basically means that the 0 we're guessing is the middle isn't actually in the middle, right? If k is greater than n, I'm saying the left side of the string before the 0 in the middle is actually bigger than the right side, so the 0 isn't really in the middle. Otherwise, the left side is shorter than the right side with the 0 in the middle, so again, 0 is not actually in the middle. Or the symbol in the middle is not a 0, it's a 1. Okay, so these are when we're going to fail. Alright, so with all of this in mind, let's go ahead and actually build our PDA. And let's see if we can make this design a reality. So here's P. P is our PDA. We're going to start out in Q0. What's the first thing that we need to do? We are going to read nothing, either from our input or our stack. And we're going to push a $sign. This is going to indicate the bottom of the stack, which is just a convention that we use to make sure that we can actually empty our stack. We can detect the bottom of the stack. Okay, so this is going to move us to state Q1. So really, Q1 is where our computation starts. Q0 to Q1 was just setting up our stack. Okay, so in Q1, this is phase 1. Okay, so here I'm going to be pushing a pound symbol to the stack for every symbol I read from my input in the first half of the input. Okay, so if I read a 1 in the input, I'm not going to look at my stack. I'm just going to go ahead and pop a pound symbol. Push a pound symbol, sorry. Excuse me. Likewise, if I read a 0, I don't need to look at the stack. I'm going to push a pound symbol. Okay, and I'm going to keep doing this for the first, we've called it W1, the first kind of half of the string. When do I stop? Well, non-determinism. So non-determinism allows me to guess the middle of the string and move over to state Q2, and Q2 is really the beginning of my phase 3. So we said phase 2 allows us to transition from phase 1 to phase 2. In this case, I need to read a 0, I don't need to look at my stack, and I don't need to do anything to my stack. Okay, it's just a transition from phase 1 to phase 3. Okay? What do we do in phase 3? In phase 3, I'm going to read some symbol from my input, and I need to pop a pound symbol off of my stack, and I replace it with nothing. Okay, likewise, 0, pound, nothing. Okay, so you can see in state Q1, which I've identified as phase 1, we're just going to read the left side of the input, and we're going to push a bunch of pound symbols. Some point we guess that we're at the middle of the string. We read that 0 in the middle. We don't do anything to the stack. We move to Q2. In Q2, we're going to read the right-hand side of our string, and for each symbol that we have in the right-hand side, we're going to pop off a pound sign from our stack. Okay, so notice here that this taking this transition requires there to be a pound symbol on the top of my stack. So if I didn't push enough in phase 1, if I had said if k was less than n, if the first half of the string was shorter than the second half of the string, I'm going to run out of pound symbols. I'm not going to be able to continue to take these transitions. So that's going to become a problem. However, if I push k symbols and I pop n symbols, and they're the same, k equals n, I'm going to get to a place where I have removed all of the pound symbols off of my stack. So now, this is where that Q0 to Q1 comes in handy. Now I'm looking at a $sign on my stack. Okay, what do I want to do here? I don't want to read any input. Okay, because by the end of Q2, by the time I've taken that loop, I've read all the input. I better have read all the input. Okay, so by reading no input and seeing that $sign on my stack, I can just pop it off and move to Q3, which is my acceptance state. Okay, so notice here, let's do a couple of short examples. So let's make sure that we can read. So let me make a little bit of room here, separate this. And let's maybe do like 3 short examples. Okay, so first one, string 0. That's a good string to check, right? Okay, so I'm going to let this be my stack here. Alright, so I start up my machine, I enter Q0, it tells me read nothing and add a $sign to your stack. At this point, I could start taking the loop in Q1 and pushing some things to my stack, but then I'm not going to have an input symbol to read to go from Q1 to Q2. So non-determinism, we're going to take the path that works. So after getting into state Q1, I'm immediately going to read I'm going to read 0 for my input, not going to touch my stack, and I'm going to move to Q2. Okay, notice here now, I have no input left. I can't take any of these transitions on the loop in Q2. The only thing I can do is read nothing, pop the $sign off my stack, push nothing to my stack and go into Q3, and accept. Okay, so this accepts 0. Let's try another string. Let's try a slightly longer one. Let's use 1 0 0 1 0. That sounds good. Okay, so I need a bigger stack for this one. Alright, so I start up my machine in Q0. I add a $sign to my stack by reading nothing either from the input or from the stack, and I'm in state Q1. Alright, in state Q1, I'm going to read a 1 from my input, nothing from my stack, and I'm going to push a pound symbol. Go back to Q1. I'm going to read a 0 from my input, nothing from my stack, and I'm going to push a pound symbol. Okay, now here, again, I could keep taking these loops, but that's going to cause a problem later. So my machine is non-deterministically going to guess the right path. So I'm going to guess that this is the middle of the string. I read the 0, I read nothing from the stack, I push nothing to the stack, and I go to Q2. Now I'm in Q2. I'm going to read a 1 for my input. I'm going to pop off a pound symbol, and I push nothing to the stack. Okay, I'm still in Q2. I read a 0, I pop off a pound symbol, and I add nothing. Okay, so now I have no input left. I have a $sign on my stack, so I can take this transition from Q2 to Q3 by reading no input, popping the $sign and pushing nothing else, and ending up in Q3 and accepting. Okay? Alright, let's try a string that doesn't work. Let's just try... let's try this one. Okay. So here's my stack. Start off the machine, put a $sign on my stack. I'm in Q1, I'm going to read a 1, and I'm going to put a pound symbol. Okay, let's say that the machine guesses now that this 0 is the middle of the string. So I would take from Q1 to Q2. So now I'm in Q2, I see a 0, so I pop $sign. I'm sorry, I pop a pound symbol. Okay, I go back to Q2. Now I have a 0 in my input, but I have no pound symbols on my stack. Okay, so I cannot take that loop. What I can do is I can go from Q2 to Q3 by reading no input and getting rid of this pound symbol, right? So now I'm in Q3. Problem, I still have an input symbol to read. Okay, so I can't stop. I can't stop and accept because I haven't read all my input. So this is where we say we implicitly would go to a reject state. Or we can also say that since my machine has to read all of the input, I can't stop in this accept state, so I can't stop and accept. Okay, so I could build another transition from here. So I could build something called a dead state or something that says once I'm here, if I see, you know, a 0 and I don't care what's on the stack and I don't care what's on the stack, I go to a dead state. So I could do that, but it's not really necessary based on how we define these machines. So that was one choice. I did have another choice that the machine could have taken, so let's try that one. Alright, oops, that's okay. Alright, so we start off, we put a $sign on our stack. I read the 1, I add a pound symbol. This pen is not great. Alright, last time I said immediately go to the 0, go to Q2, so I'm not going to do that this time. I'm going to say, okay, this isn't the middle of the string. I'm going to read a 1, I'm going to read a 0, push a pound, and now here I could guess, okay, this 0 must be the middle of the string. So I read it, I do nothing to my stack, I go to Q2, I'm in Q2 now, I'm going to read a 0 and pop a pound symbol. Okay, but now here, I still have a pound symbol on my stack, but I have no input left to read. So I can't take the transition over to Q3. I don't have the $sign on the top of the stack. I have the pound symbol on the top of the stack. Okay, so I can't transition in the accept state, and I have no more input, so I basically stop in Q2 and die. Okay, I can't accept. All right, so last, let's give, so now we're kind of convinced now that this works, so let's just give the formal definition of this machine. So let's remember that P is a PDA, and so its description looks like this. Okay, and let's define each of these. Q is going to be the set of states we had Q0, Q1, Q2, and Q3. Sigma, our tape alphabet, was 0, 1. Our stack alphabet was, what was it? It was $sign, pound sign. Okay, Q0 was our start state, that's already listed. F, our set of final states, was just Q3. Okay, and then last, we have our transition function. Hopefully I can fit this all on one page. So I have delta of Q0 reading no input, nothing from the stack, goes to Q1 $sign. Okay, I also have delta in state Q1. If I read a 0 in my input and don't touch my stack, I can go to one of two places. I can go to Q1 and push a pound, or I could have taken that transition over to Q2 and done nothing to the stack. Okay, delta of Q1, if I read a 1, here my only choice is to, and I can make all of these sets just to be precise. My only choice here was to stay in Q1 and push a pound. Okay, so now we have some transitions from Q2. If I'm in state Q2 and I read a 0 with a pound symbol on the stack, then I'm going to go back to Q2 and I'm going to push nothing to the stack. It's the same transition from Q2 on a 1. Okay, and then last, how do I accept? I'm in Q2. I read nothing from my input. I read a $sign off the top of my stack, and I go to state Q3 and I push nothing. Okay, so double check, but that should be our transition function as we created it in the state diagram. Okay, so we now have our PDA fully defined, state diagram and formal description. So this is the PDA-P for this language.